So let us see on how we can be able to understand about the motion of the electric charge in a uniform electric field. Let's say we have the uniform electric field region. Let's say this is the region of the uniform electric field. If we are saying the uniform electric field region, it is the region in which the electric field at each and every point, rather intensity of the electric field is the same. And the typical example of a system with a uniform electric field, it is the region between the parallel parallel capacitor. That is, as you can remember. So let's say this is the region of the uniform electric field, in that case, given as that one. And let's say we have a charge within the region. Let's say it is given as the positive charge. I'll go it as, let's say it is given as the positive charge. Now, according to the principle behind, you should have to expect that whenever in the electric field there is a presence of the charge, and that particular charge experiences the force in two of the conditions. When the charge is a positive charge, then the force it experiences, it is towards the direction of the electric field lines. So in this case, since this is the positive charge, it will experience the force towards the same direction. And likewise, if it is negative charge, it means it experiences the force towards the direction against the direction of the electric field lines. So keep that in mind. And for the sake of interest, what we have here is a positive charge. So it will experience the force towards this direction. And the force will be electrostatic force, given as Fe. So we should have to understand that wherever there is a force acting on the object and the object happens to move, then we can be able to apply then that particular object, and that particular force causes the object to accelerate. And for that case, this force that is acting on this charge will make the charge to accelerate towards the same direction. And let's consider the charge being of mass given as m. Then according to the Newton's second law of motion, the acceleration that the force is going to experience will be given as the force is equal to mass times acceleration, of which the acceleration will be given as the force divided by the mass of the charge. This is how the acceleration will be given in that case. And how about this electrostatic force? Well, the force will be given as the electric field times the charge. And basically, the charge has to be the magnitude. And even if it can be negative charge, we'll have the absolute value of the charge that will be given as the positive charge. And which means we can be able to have the acceleration of the object in the region of the electric field, and using this actually a formula in that way, where electric force is given as electric field times the charge itself, in that way. So since this is the region of the uniform electric field, then the force in which the charge is going to experience also be actually a constant force, also be a uniform force, or we call it as a constant force. And the acceleration that this force will also brought about will be also constant acceleration. So this charge will move at a constant acceleration in that case. So now, since the object will be moving at a constant acceleration, then we can be able to apply the equations of kinematics to describe about the motion, either the distance covered, the initial speed, final speed, and even the time takes as well to reach at some point. So which means these equations will be highly used. these are the equations of kinematics. That is, the average displacement, average speed will be given as initial speed plus final speed divided by 2, and I also have the average displacement, that is given as u plus v over 2, and that times time, and we also have what we call a final velocity is equal to at plus u, and we also have displacement is equal to ut plus half ad square, and finally we have final velocity is equal to initial velocity plus 2as. So these are the equations that you have to use, and in order to describe the motion of the object actually the motion of the charge in a uniform electric field region. So that's how you should have to get it in that way. Let's see some of the questions associated with this kind of a context and appreciate. So let's say this is the question. A proton is released in a uniform electric field, and it experiences an electric force of, now we have electrostatic force, that is 1.86 times 10 to the power 14 newtons, and toward actually the south. So which means this is the direction of actually electric force, that is, I should say a south direction. And the downwards, that is the direction of electrostatic force the electron actually experiences. Mind you, electron is a positive charge. And the question says that we should find the magnitude and the direction of the electric field. We should have what we call the electric field. But what is the charge of the actually a proton? Now the charge of the proton is a positive charge, which is given at 1.6 times 10 to the power, and that should be negative 19 coulomb. Now how should we have the electric field? So electric field will be given using the formula electrostatic force divided by the charge, that is a positive charge. Then we'll be able to have the electric field in a Newton per coulomb. So what is the direction of the electric field? So we should have to understand that a positive charge experiences the force towards the direction of the electric field. So which means the direction of the electric field, it is the same as the direction of the force, and this is for the positive charge. And if it could be negative, it means the direction of the electric field could be otherwise, in that way. And let's have to consider this another question. The question says a downward electric force of, now that is electrostatic force, that is 6.4 newtons, is exerted on the charge. And what is the charge? Negative charge, which is negative 7.3. What is micro times 10 to the power negative 6 coulomb? Mind you, the charge has to be in coulomb. And the question says, what is the magnitude and the direction of the electric field, if that's the case? So in this case, the force is acting downwards. That is the force acting downwards. And it is acting on a negative charge. So since it is a negative charge experiences the force, the negative charge experiences the force in opposite with the direction of electric field lines. So which means electric field will go opposite. So keep that in mind. That is the direction of the electric field. Now how should we have the electric field? Or have it as electric field is equal to, electrostatic force, and divided by the magnitude of the charge. So which means charge will be given as the magnitude in that case. So that's how you should have to get it in that way. Now let's say this is the question. Determine the magnitude of the acceleration. Now we are looking for the acceleration. Oh, I just have to say acceleration is a magnitude. We are looking for the acceleration of an electron. So we need the mass of the electron. That is the mass of electron. We need that one. And we also need the charge of the electron, which is the negative charge. It's given as negative 1.60 times 10 to the power negative 19 kilo. And we have been given the magnitude of the electric field, that is 756 newtons per kilo. So what is the mass of electron? So the mass of electron is given as 9.10, should have it as 1.11 times 10 to the power, let's say, negative 31 kgs. That is the mass of electron. Now we are looking for the acceleration. So we're going to use the Newton's second law of motion. Acceleration will be given as electrostatic force divided by the mass of electron. And what is the electrostatic force? Now this one is given as electric field times the magnitude of the charge. That will be given as the charge of the electron. So despite negative, we'll be using as a positive. We'll put it here. This is the mass. We'll have the acceleration. So we have another question down on the same case. The question says, how does the direction of acceleration depend on the direction of the electric field at that point? So you should have to understand that this is electron, and it is the negatively charged. That is the electron and the negatively charged. So let's say we have the electric field lines, electric field going towards this direction. Let's say towards this direction. This is the electric field. The force this charge will experience will be towards the other direction. Since this is the negative charge, it will experience the force opposite to the direction of the electric field. So hence, what will make this charge to move, it is the force. Then the charge will move towards this direction. Likewise, if it is a positive charge, the force that it will experience will be towards the direction of the electric field. And in this case, the acceleration also will be towards the same direction. So the way I've explained here, how do you think we can elaborate the proper response for that? Mine was just an overview on how you should have to expect the response to be based from. So try to have that, and I want to see the response in the comment section below if that's the case. And now this question says that an electron is released from rest. So which means its initial velocity is given as and in a uniform electric field and accelerates to the north. So that is the acceleration. That is 105 meters per second square, and that is towards the north direction. Now the question says that find the magnitude in the direction of electric field this electron experiences. So since the electron is moving towards the north, it means that is the direction of the force the electron is experiencing. Mind you, the electron has to move towards the direction of the force, as it is the one responsible for the motion. So since electron is negative, it means electric field has to go in a southward direction. So keep that in mind. Then how should we have the magnitude? How should we have the magnitude of the electric field? So electric field will be given as using the formula electrostatic force divided by mass of the electron. But how should we have the electrostatic force? Now, this particular electrostatic force will be in the same as the actually gravitational force, that is mg. We'll have this substitute here, we'll have the now not mg but mass times acceleration, that is simply the acceleration that we have. Mind you, I've been given acceleration. We'll multiply here with the mass, and we'll have, of which the mass, it is the mass of a proton, actually rather electron, and I'll be able to have the electric field in that way. And now let's say we have this question: an electron with a speed of, now that is the initial speed that it will be given as, that is the initial speed, that is given as 5 point. Mind you, initial speed is the same as the initial velocity, and times 10 to the power is 6 meters per second, and is traveling prior to the electric field of magnitude. Now that is the electric field, the magnitude 9,000 newtons per kilometer. Now the first question says that how far will the electron travel before it stops? Now we are looking for the displacement, and where final velocity is given as well. We are looking for the displacement where the final velocity is given as well. Now in this case, we're going to use the equations of kinematics, and which equation incorporates the final velocity, displacement, as well as the initial velocity, and that is v square is equal to u square plus 2as, where we are looking for the displacement. Since we have initial as well as the final, we're going to have acceleration using Newton's second law of motion. That is, acceleration is given as Fe divided by the mass of electron, and of which this one will be given as electric field times the charge. That's how you have it. And the question B says that how much time will elapse before it is stopped. So now we're looking for the time. So which formula should we use to have time? You may think of either using final velocity is equal to at plus u, that will work as well. Either using the displacement formula, that is ac is equal to ut plus half at squared. So that one will work as well. And the other question says that, so how much will it elapse before, I should say that what's the question A? Question A says that how far will the electron travel before it stops? That is part A. And the question B says that how much time will it elapse? Actually, let's use it as before it stops. Let's go it in that way, before it stops. That's what we are to calculate as B. And let's see, actually let's have a part C as how much time will it elapse before it returns to its starting point. What do you say? Try that one. And now let's also consider this question. A proton is projected in the positive x direction into a region of electric field of, now that is the electric field, that is 600,000 newtons per coulomb at a time t is equal to 0. That is the starting time. Now the proton traveled some distance, that's the displacement, 7, what is sent, times 10 to the power negative 2 meters. It comes to rest, which means the final velocity is given as 0. So there's no any information to do with initial velocity, otherwise we have been given the question to find the initial velocity. So don't confuse things that the fact that a t is equal to 0, it means initial velocity is also 0. No. And the question says that find the acceleration of the proton. we are looking for the acceleration, and that will be given as Fe, that is electrostatic force divided by the mass of electron, where Fe is given as Eq. So we know that the electron, actually a proton, is having its own actual charge that are going to use or have acceleration, and from there we'll have the initial speed. You choose which equation suit for that, and also the time takes as well. You also choose the time which is suit for that. So keep that in mind. And finally, let's pay much attention and on this question. And now let's say we have also this other question that we can also look up to. An electron and a proton are each placed at rest in a uniform electric field of magnitude that one. Calculate the speed of each particle in 48.0 nanoseconds after being released. So we have two charges, electron as well as the proton. So this is for electron, this is the proton. I'd say for proton. And we have initial velocity here L, and also here given as L. And we have their charges, that is a negative charge, we know that, and this is the positive charge, we know that. And the electric field both is the same, 5.2 newtons per kilo, and also a 5.2 newtons per kilo. That is electric field for all. Now the question, now we have the time for both, that is 48.0. What is nano times 10 to the power negative? Should be, what is nano? Should be to the power negative 9 coulomb. And also this one, the time with the same, 48.0 times 10 to the power negative 9. It should be seconds, not coulomb, but should be seconds. So should be seconds, not in coulomb. So seconds and also seconds. So the question says that we should have to calculate the final speeds for all. So try to calculate what is their respective speeds after 48.09 nanoseconds has elapsed. So here is the question for you as well. A uniform electric field of magnitude, that one, exists between two parallel plates, and that are 4 cm apart. A proton is ejected from rest at the positive plate, and the same instant electron is released from rest at the negative plate. A. Determine the distance from which a positive plate, I should say, determine the distance from the positive plate at which two pass each other. Now we are looking for the distance in which, I should say, from which a proton has to pass or meet with electron, in that case from the positive plate. So it should also do the same with what if we have a sodium ion as well as the chloride ion. What did you say? Now understanding of this question requires you to actually check or review about the video we discussed about the applications of the linear kinematics in basically head-on case. Where we have two objects moving towards one another like that, and having some distance, let's say given as t, away from each other. Where are the two are going to meet, and what is the distance this one has to travel, and also distance this one has to travel as they are going to meet, and also how long will it take for each to meet at the point between the two. Now the understanding of that one requires you to understand about this one. So try to review that one and to be able to handle this final question. Thank you for watching, but don't forget to subscribe and share as well, as you'll be notified for whichever the content has been created, which is good for your academic journey. Thank you.